Hello guys, welcome you all for this end-to-end session of data science where you're gonna learn everything that you guys need to become a successful data scientist. That is like combination of artificial intelligence, machine learning, deep learning, natural language processing, generative AI, everything you guys gonna learn. So it's gonna be a year-long program. So yeah, guys. So hope you guys are enjoying. We are enjoying a lot, and we are learning a lot. Hope the same thing for you guys. So before going for the session, make sure you guys watch all the previous session videos so that you can have a continuation of what we are telling. Okay. So today is going to be the continuation session of previous session where we have introduced you the LDA, the black box of it, and the max of it. So these are the things that we have done in the previous session. Let's go for the today's session. So today's session we're going to continue the LDA. So but like I request every one of you, please make sure that you guys watch all the previous session videos so that you can have a continuation, guys. That's the only thing I'm just asking you guys to do. So yeah, guys. So let us without wasting any time, let us jump into today's session. Okay. Yeah. LDA versus PCA. Hope 3 sessions we have done for PCA. Now to understand the theory concept, black box, and then coding session. LDA we have done one session. Now let's see what is the difference between LDA and PCA. LDA and PCA both are dimensional reduction technique. Yeah, that's true. But their objective differ. While PCA aims to find the direction that maximizes the variance in data, LDA focuses on finding the direction that maximizes the separation between data. That's right. What PCA does, it tries to maximize the variance within the data, like variance in the data, so that it can create a principal component. Whereas LDA, it maximizes separation between two classes. Okay, hope you guys can able to understand. In PCA, we maximize the variance in the data, within the data, that is in the data. Whereas LDA, it is used to maximize the separation between classes. Hope you guys can able to understand. Next, LDA is a supervised technique. I have said right. It is a special case. It's a dimensional reduction technique, but LDA is a supervised learning because we will be having labels. Whereas PCA is unsupervised. We don't have any labels. Okay. Let's see. What is PCA? It maximizes the variance in the data so that it can create a principal component and it can convert the high dimensional data to low dimensional data. Whereas LDA, it maximizes the separation between classes such that it can create a classification kind of thing using dimensional reduction itself. Okay. And PCA is a unsupervised learning, whereas LDA is the supervised learning. That is what the difference between LDA and PCA. Hope you guys can able to understand and you guys are able to see the figure right. So here we will be having a principal component to separate the values, whereas LDA tries to split the data as much as possible so that we will be having different classes and we will be having more separation between them. Okay, so hope you guys can able to understand. So yeah, that's all about LDA versus PCA. So yeah, sir, anything that you need to share related to this, sir?
Yeah,
Related.
so LDA
Yeah,
versus
that's it.
PCA. So LDA and PCA both are dimensionality reduction techniques. That is the similarity, but their objective differs. While PCA aims to find direction, the maximize variance in the data. That is the PCA's characteristics. LDA focuses on finding direction that maximize the separation between classes. One is finding direction, one is reduce it's like if you see both are dimensionally, but their PCA aims to find direction that maximize variance in data, maximizes the variance in data. Okay, finds direction that maximize. Then LDA it maximize the separation of the classes. Okay, these are two different, there's a difference. Okay, LDA is a supervised technique while PCA is unsupervised. These are two different things with LDA and PCA. PCA maximize variance in data, LDA maximize the separation between classes. So you can see visualization here. Let's move to the other section. Thanks.
Yeah, sure, sir. Let's move on. So I hope like we're gonna we are coming to an end of this. Okay. So let's see what are the advantages and disadvantages of LDA. LDA offers advantages like its simplicity and effectiveness in reducing dimension while preserving class separability. However, its performance can be affected by presence of outliers or nonlinear relationship in the data. LDA is also sensitive to distribution of data and may not perform well in the assumption of normality and equal variance are violated. Okay, let's separate this. How? Let's see. Advantages: it is simple and effective dimensionality reduction technique. Yeah, it's very simple. What we will be doing? We will be doing within class less variance, between class more variance. It's simple, right? That's the reason it is an advantage. Disadvantage: sensitive to outlier and non-linear relationship in the data. Yeah, the name itself, it's a linear discriminant analysis and it will be using a line to separate the things. So that's the reason it is very sensitive to outlier. So when you are having a non-linear data, it is not able to work. You are having a polynomial data, how a line will work? Okay, that's the reason it will fail there. Okay, not it will fail, it will try to their accuracy will be less. Okay, because like for a polynomial data also the linear line can fit, but like not to the extent. Okay, so yeah, this is a disadvantage of LDA. So as we have discussed the advantage and then disadvantage of this LDA method. Yes, sir, over to you.
Yeah, so everything has two sides. Okay, so let's see. LDA offers different advantages like simplicity, effectiveness, reducing dimensionality while preserving class separability. So that is what is this. It always separates two classes, right? That's what is LDA. So that there's no mix of, right? So when it gets the insights or inference out of it, so that's not mixed, okay? Everything is separate. So however, its performance can be affected by presence of outliers of non-linear relationship in data. LDA is also sensitive to the distribution of data, okay? May not perform well and assumption of normality and equal variance are violated. So like these are the advantages. Okay, then we have advantages: simple, effective dimension reduction technique. Disadvantage: sensitive to outliers, non-linear relationship in the data. So this is how it will, like, if you have seen assumptions, like wherever we have a um, assumptional problem where we have to assume, like model has to assume, so it may not work well. Okay, so that is the difference because of class separability and sensitive to outliers and stuff. So let's move to the other section.
Yeah, sure, sir. Let's move on. What we are having. Okay. Application of LDA in data science. Let's see what are the applications that we are having for LDA. Okay. LDA finds application in various data science tasks. It is commonly used for classification problems like image recognition, text classification or categorization, and then spam detection. LDA can also be applied to medical diagnosis, customer segmentation, and fraud detection. Okay, I will say in a simple manner, it can be applied to any field where we can apply AML and DL. Wherever the data science can be helpful, and I will not put it in this way. Whatever the industry there, we can use this LDA. Okay, let's see. Because like this slide can accommodate only four things, so I am just putting four things. Image recognition: classify image based on their content. Yeah, LDA can do it based on the separability that it is having, right? Based on that, it can go for image classification recognition. Text classification: categorizing documents based on their topics. Yeah, what it will do means it will try to create a separability between the classes so that you can find the category of document based on their topics. Then medical diagnosis: it assists in diagnosing medical conditions. Okay, like this is a major thing. So like we will be having multidimensional data. It tries to create a separation between them and it will try to predict and helpful for this medical diagnosis kind of thing. Okay, customer segmentation groups the customers based on their behavior. Yeah, this is a customer who has more salary and they are spending more, less salary spending more, less salary spending less, more salary spending less, like that. This kind of thing we can do it by using this LDA. Okay, so these are the applications that we are having for LDA. So in data science, okay, I will not say this is limited to this. There are n number of applications which has the uh, which requires this LDA. Okay, so yes, sir, over to you.
Application of LD in data science or AIML. So it helps us image recognition, classifying image based on their content. Okay, text classification, it will help us categorizing document based on their topics. Okay, or metadata. So medical diagnosis and assisting in diagnosing medical conditions. Customer segmentation again, X number of healthcare, obviously deep learning and other text wherever document, customer segmentation, whosoever has customers and wants to do customer segmentation, grouping customers based on their behavior so that you can target well and to try to improve your sales and profitability. Let's move to the other section. Thanks.
Yeah, so these are all the applications. So we are having a number of applications for LDA. Let's move on to the next thing. Okay, let's conclude this. Okay, conclude this LDA, and we will look into the coding session in the next session. Okay, so yeah, conclusion and key takeaways. LDA is a powerful and versatile technique for dimensional detection and classification. It is a valuable tool for data scientists, yeah, offering an effective approach to handle high dimensional data and extract meaningful insights. Understanding the assumption and limitations of LDA is crucial for successful application. Yeah, all the algorithm acts as its own advantage and disadvantage. We need to find those things, and we need to, as a data scientist, we need to apply wherever it will be effective. These algorithms work effective. Okay, now effective LDA is an effective technique for reducing dimension and improving the classification accuracy. That's true. Then versatility, LDA finds applications in a wide range of data science tasks from image recognition to medical diagnosis. Yeah, a number of applications, so it is versatile. Understanding limitation, it's important to be beware of assumptions and limitations of LDA for optimal application. Yeah, it can treat only linear data. Okay, what if I'm having a non-linear data? I'm just trying to use the LDA. I'm just getting only 50% of accuracy. I'm just trying to say this LDA is not working fine for my data set. Since my data set is not linear, it's obvious that LDA will not work. You need to go for some other thing which can support the non-linear concept. Okay, so yeah, by using this advantage and the disadvantage, understanding your disadvantage, we can have a proper application where this LDA can work perfect. Okay, so yeah guys, I this is what all about this LDA. So hope you guys have understand. If you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubts. So yeah sir, over to you.
So, conclusion and key takeaways. We have to take away from something from this session, guys. Otherwise, this session will not complete. Okay. So remember this. So, LDA, the first effective key takeaway conclusion is LDA is effective technique for reducing dimensionality. So I'll say PCA, LDA, all these are for dimension reduction, but they have their difference. One is separability. LDA works on separability of the classes, and PCA works the reducing the, like, it will check the variance and reducing higher dimension. Both have the same, but there is a little difference. Improving classification accuracy, that is the effective. Versatility is LDA finds application in a wide range of data science tasks from the image recognition and medical diagnosis, which we have seen in application. Understanding limitation, it is important to be aware of the assumptions and limitations of LDA optimal for the optimal application. So everything has limitations, and we are always probabilistic even for the models which predict the probability of uncertainty. So we are always probabilistic for everything. As data scientists, AIML researchers, we are always probabilistic until unless we reach a stage where super intelligence predicts 100%. Okay, so we'll have different models for that, or general intelligence solves all general problems, hard problems and soft problems. Okay, let's move to the other section. Thanks a lot. Keep learning deeply.
Yeah guys, so this is all about today's session guys. We have understand the black box behind the LDA, and then mathematical concept behind the LDA and theoretical concept behind the LDA. Everything is fine. Okay, next session we're gonna look into the coding part of LDA. Hope you guys have enjoyed this session. Please make sure that you guys watch this complete session, previous session and today's session, so that the LDA will complete. Because like yesterday we have introduced the mathematical concept of LDA. Today we have just completed the theory concept of it. Hope you guys have understand. If you guys have any doubt, just ping in the comment section and we will take up and we will solve your doubts. So yeah, in the next session we will just see the coding part of LDA. So guys, until next session, bye guys, take care, and we will all meet in the next session. Bye guys.